Good morning. We are going to start our review for the AP test with limits today. So we're going to find limits graphically first, and then the next video we'll do limits analytically. So what is a limit, right? What is a limit? So if we look at a graph, let's say we've got a graph here and we've got some different, let's say we come up and we've got a nice hole here and something like that, and then we come up and another open circle, and then let's say we've got a line here. Okay, something like that, right? Some crazy function here. So whoops, and this is f of x, right? X. Okay, and we want to know, let's say, the limit, and we'll call this A. So this point here. This point is a good one, right? So if we talk about limits, we always do a three-step process. We always look at the limit from the left and then we look at the limit from the right, and then we decide, is there a limit? Okay, so the limit from the left here, limit as x approaches a, and we show from the left with this negative symbol, so it's on the negative side of a, or the small side of a here, of f of x. And we can say, oh, okay, this is 1, 2, maybe 3 here, right? So as we come up, as we follow or trace our function, we're tracing our function, and we're getting closer and closer to A in the x direction, what value are we approaching in the y direction? And sure enough, we're getting closer and closer to 3. So I'm going to say, okay, that equals 3, right? And if we do the same thing on the right side, we're tracing the function. You can do this with your finger too. Sometimes I just follow it along. And we're getting closer and closer to A from the right. We'll put a little plus sign here and a minus sign here. And we're getting closer and closer to 3. So I can say, okay, the limit from the left is 3, and the limit from approaching from the right, and we can show that the limit as x approaches a from the positive side of f of x is also equal to 3. So that's important, right? So we have the same answer. So if you get the same answer, the limit exists. Oh, and I'm off the paper. Limit exists. Sorry about that. So now we can say, therefore, the limit as x approaches a of f of x is equal to 3, and the limit exists. So this is step 1. I kind of did this in a weird order. Step 1, step 2, and then step 3 finally is saying, okay, if these two are both the same, then the limit does exist and it equals that number. Okay, so let's look at this point here. We'll call this point B, and we'll do the same thing, right? So we can say, okay, so for B, from the left, we've got the limit as x approaches B from the left of f of x, and from the right, the limit as x approaches B from the right. And let's say that is going to correspond to, what do you think? We're going from the left here and the right here, and we're both approaching the same number, which looks like you got it. -2. So therefore, because those two are the same, therefore the limit exists. The limit as x goes to b from f of x is equal to -2. And you're done. Now, what's going to happen here? Oh, we did A, we did B. Let's try this point, C. Okay, so we're going to do from the left and from the right. Okay, so the limit as x approaches C from the left, it looks like we're approaching 2, +2, and the limit as x approaches C from the right, that looks like now we've got this disconnect, right? Now where that looks like maybe +4, right? F of x is equal to 4. So the one-sided limit exists, but the actual limit at C does not exist. So therefore, the limit as x approaches C of f of x equals D, and E does not